we need to look at the introduction to stellar formation. In particular, what is the Jeans criterion? This is not the Jeans criterion, excuse me. The Jeans criterion is about stellar formation, and here we have it. You know that if there's enough mass here, in other words, if we've got a greater than a critical value, which is mj, the gravitational forces will be great enough so that they exceed the forces due to the kinetic energy of the particles, in other words, the thermal energy of the material. And if that's the case, the gas cloud will collapse and we will form a protostar. So what decides whether the star will form? What is this Jeans criteria? Well, you know that particles come together basically by their mutual gravitation. But you need a certain density and a certain volume and therefore a certain mass to be able to contribute enough gravitational force. It also needs to have quite a low temperature. If the temperature is too high, then the particles have too much kinetic energy and they will escape from the mass of the gas. So, this mass of gas is more likely to collapse if the prestellar matter has 1. A large mass, 2. A small size, and 3. A low temperature. And as far as points 1 and 2 are concerned, you can think of the force, the gravitational force due to Newton's law. It's a product of the masses. Also, it's inversely proportional to the square of the size. So you can understand that. The low temperature is needed because you don't want the particles to be escaping. Another way of looking at it is that the kinetic energy and the potential energy of all the particles must be less than 0. Then the star will form. Remember that potential energy is negative because it has 0 potential energy at infinity. So the magnitude of the potential energy must exceed the magnitude of the kinetic energy of the particles. So the Jeans criterion is this. If the mass is greater than the mj, the Jeans mass, then the star will form. And this Jeans mass, mj, is given by this equation: 3 times by k, Boltzmann constant, times by the temperature, times by the radius of the mass, divided by 2gm, where m is the mass.